Hello everyone, I am Kaushik Mulpuri. I am from Sri Venkateswara College. I am here to explain NoSQL databases. Uh, I am going to cover these topics, key value databases, documented databases, column oriented databases, graph databases. First, key value databases. Data model key value databases store data as a collection of key value pairs. Each key is a unique and maps to a value. What are the uses of this? There are suitable for scenarios requiring fast data retrieved based on a known key such as caching, session management, and simple data storage. Performance. Key value databases offer excellent performances for read and write operations, making them suitable for high throughput applications. Key value databases. Its scalability. They can scalable horizontally by adding more nodes to a cluster, distributing the data across multiple servers. Example, Redis is meme cached Amazon data DynamoDB. Documented databases. Data model. Document databases store semi-structured data as documents, typically in JSON or BSON format. Each document can have its own structure schema. What are these use cases? They are suitable for content management system, real-time analytics, and applications with flexible schema requirements. Document databases. Performance. Documented databases provide efficient querying based on the document structure and can handle complex queries. Scalability. They can scale horizontally by sharding documents across multiple nodes, allowing them to handle large data sets. Examples: MongoDB, Couchbase, Apache CouchDB. Column-oriented databases. Data model. Column-oriented databases store data in columns rather than rows. It prefers to store data in columns. Each column is stored separately, allowing for efficient storage and retrieval of specific columns. What are these use cases? They are suitable for analytic workloads, data warehousing, and scenarios requiring aggregations and analytics over large data sets. Performance. Column-oriented databases excel at read-heavy operations, particularly when queries only involve a subset of columns. Column-oriented databases scalability. They can scale horizontally by adding more nodes and distributed column families across nodes. Examples: Apache Cassandra, Google Big Data, Bigtable, Apache HBase. Graph databases, data model. Graph databases represent data as nodes, edges, and properties. Nodes represent entities, edges represent relationships between nodes, and properties provided additional information about nodes and edges. Use cases suitable for scenarios involving complex relationships such as social network recommendations, engines, fraud detection, and network analysis. Performances. Graph database excels at transferring relationships between entities, making them efficient for graph-based queries and complex relationship analysis. Scalability. They can scale horizontally by partitioning graphs across multiple nodes and distributed data. Example, Neo4j, Amazon Neptune, Apache Tinkerpop. This is short note on difference between what we discussed in last four data models. As we see, key value store, column value store, document store have high performance of queries, whereas graph database it varies on scalability of data. Key value storage and column store has high, and remaining two document store and graph database have variable flexibility in schema. Except column storage, every data model have high structure of a database. In key value store, primary key with some value, column store, row consisting multiple columns, document store, JSON in forms of tree, graph database, graph entities and relationships, complexity of values, key values none, key value storage none, column store have low complexity, document store have low complexity of values. Graph database has more complexity of values compared to others. So thank you everyone.